October 25th, 1944. Philippine Sea, approximately 40 nautical miles east of Samar Island. Vice Admiral Takeo Kurita stood in the operations room aboard the super battleship Yamato, staring at radar displays that had suddenly transformed from precise tactical instruments into meaningless storms of electronic noise. His fleet, the most powerful surface force Japan had assembled in months, was approaching what should have been an easy victory against lightly defended American escort carriers. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The radar screens that had been tracking American ships with crystal clarity moments before now showed nothing but chaotic interference patterns, white noise that obliterated every target return. "What is happening to our radar?" Kurita demanded of his electronics officer, Lieutenant Commander Saburo Nakamura. The younger officer's hands moved frantically across the equipment, checking connections, adjusting frequencies, running through every diagnostic procedure his training had provided. "Admiral, the equipment is functioning perfectly," Nakamura reported, his voice tight with confusion. "But we are receiving powerful radio frequency transmissions on all our search radar frequencies. It is as if the Americans are transmitting directly into our receivers, drowning out the reflected signals from their ships." Kurita felt his confidence waver for the first time that morning. His fleet possessed the finest naval radar systems Japan had ever deployed. The Type 21 air search radar could detect aircraft at ranges exceeding 100 kilometers. The Type 22 surface search radar could track enemy ships with precision sufficient for gunnery solutions. Yet now, when his fleet needed this technological advantage most desperately, his screens showed nothing but electromagnetic chaos. The Americans had done something his staff had never anticipated. They had not simply hidden from his radar. They had blinded it completely. What Admiral Kurita could not know in that moment was that he was experiencing the opening move of what would become the most comprehensive electronic warfare campaign in naval history. American escort carriers, those vulnerable baby flat tops his battleships should easily destroy, were deploying radar jamming equipment that would revolutionize naval warfare. Within hours, Kurita would order his massive fleet to retreat from what appeared on radar to be an overwhelming American force, when in reality, he faced only a handful of escort carriers and destroyers. The psychological impact of technological blindness would prove more devastating than any torpedo or bomb. The invisible war had reached the Imperial Japanese Navy, and Japan was already losing. The foundation of Japanese naval confidence had been constructed carefully over decades. Since the Russo-Japanese War of 1904 through 05, when Admiral Togo's fleet destroyed Russian naval forces at Tsushima, Japanese naval doctrine emphasized technological excellence and superior training. By 1941, the Imperial Japanese Navy operated the world's most powerful battleships, the most advanced carrier-based aircraft, and the finest naval torpedoes. The long-lance oxygen-fueled torpedo could strike targets at ranges exceeding 40,000 meters with devastating warheads. Japanese optical rangefinders were legendary for their precision. Night combat training was rigorous and effective. Commander Tameichi Hara, who served aboard multiple cruisers throughout the Pacific War, wrote in his memoir, Japanese Destroyer Captain, published in 1961, that "We entered the war absolutely convinced of our superiority in night combat, torpedo tactics, and ship handling. Our training was intensive. Our equipment was first-rate. We had studied American naval capabilities thoroughly and concluded we held decisive advantages in multiple areas." If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Radar technology came relatively late to the Imperial Japanese Navy, but when it arrived, it reinforced Japanese confidence in technological superiority. The first operational Japanese naval radar, designated Type 21 Air Search Radar, entered service in 1942. Operating at a wavelength of approximately 1.5 meters on frequencies around 200 MHz, it could detect aircraft formations at ranges that gave fleet commanders precious minutes of warning before air attacks. The Type 22 surface search radar, introduced in 1943, operated at 10 centimeters wavelength and provided surface detection capabilities that transformed night combat operations. Production of these radar systems was concentrated at facilities operated by the Japan Radio Company and Naval Technical Research Institute. Each Type 21 radar required approximately 2,000 hours of skilled labor to manufacture and calibrate. By mid-1944, Japanese capital ships carried multiple radar sets, creating integrated detection networks that covered both air and surface threats. The Yamato herself mounted 2 Type 21 air search radars, 1 Type 22 surface search radar, and several Type 13 early warning sets. Her electronics suite represented the pinnacle of Japanese radar technology. Japanese naval officers trained extensively in radar operations at the Naval Technical School in Yokosuka. Lieutenant Commander Nakamura had graduated in the top 5% of his class in 1943, mastering not just operational procedures, but the underlying physics of radio wave propagation, antenna design, and signal processing. His training emphasized radar as a force multiplier that would give Japanese forces critical advantages in the surface engagements that naval doctrine anticipated. "We were taught that radar would allow us to strike first in night engagements," Nakamura recalled in a 1953 interview preserved in the Japanese Defense Agency archives. "Our radar-directed gunnery would destroy American ships before they even detected our presence. This confidence shaped our tactical planning completely." The Battle of the Philippine Sea in June 1944 had already demonstrated some concerning limitations. American fighters equipped with sophisticated radar systems had intercepted Japanese aircraft with disturbing efficiency. But Japanese naval commanders attributed these losses primarily to American numerical superiority and improved fighter tactics. The fundamental belief in Japanese radar competence remained intact. What Japanese intelligence had failed to detect was the massive American investment in electronic warfare technology. At laboratories across the United States, scientists and engineers had been developing radar countermeasures since 1942. The Naval Research Laboratory in Washington, the Radiation Laboratory at MIT, and Bell Telephone Laboratories had created an entire ecosystem of jamming equipment, chaff dispensers, and electronic deception systems. Their work, conducted under extreme secrecy, would produce technologies that could render Japanese radar virtually useless. The American breakthrough in naval electronic warfare came from recognizing that radar systems, however sophisticated, were fundamentally vulnerable to radio frequency interference. Every radar transmitted pulses of energy on specific frequencies, then listened for reflections from targets. If an enemy could transmit powerful signals on those same frequencies, the radar receiver would be overwhelmed with false information, making genuine target detection impossible. The concept was simple. Implementation required. Industrial capacity and technical sophistication Japan could not match. American factories began producing radar jamming equipment in quantities that staggered Japanese intelligence analysts, who reviewed captured documents after the war. The TDY jammer, designed specifically to counter Japanese radar frequencies, entered mass production in early 1944. Each unit weighed approximately 40 pounds, could be operated by a single technician, and transmitted powerful noise across the frequency bands used by Japanese Type 21 and Type 22 radars. By October 1944, American escort carriers routinely carried multiple jamming sets, creating protective electronic shields around their task forces. The manufacturing program proceeded with characteristic American efficiency. Companies like Hallicrafters, RCA, and Westinghouse retooled production lines to build jamming equipment alongside their regular consumer and military electronics. Workers, many of them women, recruited for war production, assembled the units with increasing speed as manufacturing techniques improved. By late 1944, American industry was producing over 500 radar jamming sets monthly, enough to equip every carrier, battleship, and cruiser in the Pacific Fleet with multiple units. The operational deployment was carefully coordinated through the Office of the Chief of Naval Operations and the Commander-in-Chief Pacific Fleet. Electronics officers received specialized training in jamming tactics at schools in San Diego and Pearl Harbor. Technical manuals ran to hundreds of pages, detailing optimal jamming frequencies, power settings, and coordination procedures for maximum effectiveness. The goal was not simply to deploy jamming equipment, but to integrate it into comprehensive electronic warfare strategies that would multiply American advantages in every naval engagement. The morning of October 25, 1944 began with Admiral Kurita's fleet transiting San Bernardino Strait under cover of darkness. His force consisted of 4 battleships, including Yamato and her sister ship Musashi, 6 heavy cruisers, 2 light cruisers, and 11 destroyers. This represented the striking power of the Imperial Japanese Navy, concentrated for a decisive blow against American invasion forces at Leyte Gulf. The plan was elegant in its simplicity. Kurita's center force would smash through the thin screen of escort carriers and destroyers guarding the American landing beaches, then systematically destroy the vulnerable transports and supply ships. Japanese intelligence estimated that only a handful of escort carriers, small, slow vessels built on merchant ship hulls, stood between Kurita's battleships and the American amphibious fleet. These baby flat tops carried obsolete aircraft and possessed minimal armor. Yamato's 18.1-inch guns could destroy them with single salvos. The operation should be a massacre. What intelligence had not revealed was the electronic warfare capability aboard those seemingly vulnerable escort carriers. At approximately 0630 hours, as dawn broke over the Philippine Sea, radar operators aboard Yamato detected surface contacts to the northeast. The returns were clear and unmistakable. American ships approximately 30 kilometers distant, moving slowly in what appeared to be a protective formation around the escort carriers. Lieutenant Commander Nakamura plotted the contacts carefully, feeding data to the gunnery computers that would calculate firing solutions once the fleet closed to gun range. Then, at precisely 0658 hours, the American ships vanished from his radar screens. Not gradually, not through evasive maneuvering, but instantaneously. One moment the displays showed distinct target returns with clear range and bearing information. The next moment, those returns were buried under a solid wall of electronic noise that made target detection impossible. Nakamura's first assumption was equipment failure. He ordered technicians to check all connections, verify power supplies, and test the radar's self-diagnostic systems. Everything reported normal operation. The transmitter was broadcasting pulses at full power. The antenna was rotating smoothly. The receiver was functioning perfectly. Yet the display showed nothing but chaos. Across the fleet, other radar operators reported identical problems. The battleship Nagato's Type 22 radar had lost all surface contacts. The cruiser Tone's radar showed only interference. Every ship equipped with radar experienced the same inexplicable blindness. Communications between ships crackled with confusion as officers tried to understand what was happening. Center Force, all ships report radar malfunction. The message traffic log preserved in Kure Naval Arsenal archives recorded. Unable to maintain tracking on American vessels. Request instructions. Admiral Kurita faced a decision that would haunt him for the rest of his life. His visual observers could see anti-aircraft fire and occasional masts on the horizon, confirming American ships were ahead. But without radar, he had no accurate range information, no precise target locations, no ability to coordinate his fleet's massive firepower effectively. Japanese doctrine relied heavily on radar-directed gunnery for engaging targets beyond visual range. Night combat tactics assumed radar would provide the targeting data that human eyes could not see in darkness. Now, in broad daylight, his radar systems were useless. The American escort carriers of Taffy 3, commanded by Rear Admiral Clifton Sprague, were indeed deploying radar jamming equipment. The USS Fanshawe Bay, USS Street Low, USS White Plains, USS Kalinin Bay, USS Kitkun Bay, and USS Gambier Bay Each carried TDY jammers operated by specially trained electronics warfare officers. These men, most of them communications specialists with only weeks of additional training, were executing procedures that would save their ships from certain destruction. Ensign Robert Hollenbach, electronics officer aboard USS Fanshawe Bay, wrote in his combat report filed 3 days after the battle, "At approximately 06:50 hours, we detected multiple Japanese radar transmissions on frequencies consistent with Type 21 and Type 22 search radars. I activated both TDY jammers at maximum power, sweeping across the frequency bands we knew Japanese systems used. Within minutes, I could hear confused Japanese voice communications over our radio intercept equipment. They were reporting radar failures fleet-wide. Our jamming was completely effective. The effect on Japanese tactical coordination was immediate and devastating. Admiral Kurita's battle plan had assumed his radar would track American ships continuously, allowing his fleet to maintain formation while closing to optimal gun range. Without radar, visual communication became necessary, but smoke, screens deployed by American destroyers, and the carriers themselves obscured sightlines between Japanese ships. Fleet cohesion began to deteriorate as individual captains maneuvered based on what they could see rather than coordinated tactical plans. More critically, the Japanese could not determine how many American ships they faced. Radar would have provided precise counts of contacts, distinguishing between the 6 escort carriers, 3 destroyers, and 4 destroyer escorts that actually composed Taffy 3. Visual observation through smoke and at ranges exceeding 20 kilometers made accurate assessment impossible. Japanese lookouts reported what appeared to be many more ships than were actually present, a confusion amplified by American radar deception tactics. USS Samuel B. Roberts, one of the destroyer escorts, carried corner reflectors, simple metal structures that created radar returns far larger than the ship's actual size. These devices, when combined with American jamming, created the radar signature of much larger vessels. Japanese radar operators, when they briefly gained clear returns between jamming cycles, saw what appeared to be cruisers or even battleships, rather than the tiny destroyer escorts they actually faced. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. Admiral Kurita, deprived of accurate radar intelligence and faced with confused visual reports suggesting a much larger American force than actually existed, made the decision that would define his career. At 09:20 hours, after less than 3 hours of combat, he ordered center force to withdraw. His staff protested. Visual observers insisted the American ships ahead were vulnerable escort carriers, not the fast fleet carriers Kurita believed he faced. But without radar confirmation, Kurita could not trust his intelligence. The electronic blindness had created tactical paralysis. I could not determine the composition or strength of the enemy force. Kurita testified to the Naval General Staff investigation in December 1944, according to transcripts preserved in the National Institute for Defense Studies in Tokyo. My radar systems, which should have provided this crucial information, showed only interference patterns. Visual observations were contradictory and unreliable due to smoke and distance. Under these conditions, I judged that proceeding against what might be a superior American force would risk the destruction of my fleet without achieving strategic objectives. The reality was that Kurita's massive battleships and cruisers had been repelled by a handful of escort carriers and their destroyer escorts through a combination of desperate courage and technological superiority in electronic warfare. Taffy 3 lost 2 escort carriers, 2 destroyers, and 1 destroyer escort, grievous casualties for such a small force. But they had saved the American landing fleet and achieved one of the most improbable victories in naval history, not through superior firepower, but through superior technology that rendered Japanese radar useless at the critical moment. For Japanese naval officers analyzing the battle in its aftermath, the implications were profoundly disturbing. If American forces could blind Japanese radar at will, every assumption underlying Japanese naval doctrine required reconsideration. Radar-directed gunnery, the foundation of Japanese expectations for night combat superiority, was vulnerable to countermeasures Japan could not deploy in return. Surface actions that doctrine said Japan should win through superior night fighting skills could be neutralized by electronic warfare capabilities Japanese industry had not developed. Lieutenant Commander Nakamura, writing in his personal journal on October 30th, 1944, captured the psychological impact. "We have discovered that our radar systems, which we believed gave us parity with American technology, are completely vulnerable to jamming we cannot counter. The Americans possess electronic warfare capabilities we did not know existed. More disturbing, they can deploy these capabilities from even their smallest carriers, suggesting their industrial capacity to produce such equipment far exceeds our own. We are fighting blind against an enemy who sees clearly." The Battle off Samar was not an isolated incident. Throughout the Philippines campaign and subsequently at Okinawa, Japanese naval forces encountered American radar jamming with increasing frequency and sophistication. Each engagement reinforced the same lesson. Japanese radar could not be relied upon when American electronic warfare equipment was present. The technological advantage Japan had believed radar provided had evaporated, replaced by a new form of asymmetric warfare where American forces held overwhelming superiority. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Japanese response to this technological shock was hampered by the same industrial and scientific limitations that plagued all Japanese weapons development late in the war. At the Naval Technical Research Institute in Yokosuka, engineers began crash programs to develop countermeasures, techniques and equipment that might allow Japanese radar to function despite American jamming. The challenges were immense and the resources inadequate. Captain Yatsuko Omi, director of radar research at the Naval Technical Institute, later told American interrogators in October 1945 that, by late 1944, we understood that American jamming equipment operated by transmitting powerful radio frequency noise across the bands our radars used. The theoretical countermeasure would be frequency-agile radar systems that could rapidly change operating frequencies, forcing American jammers to track and adjust constantly. Developing such systems required electronic components we could not manufacture in sufficient quantities and time we did not have. Japanese attempts to develop frequency-agile radar founded on fundamental industrial limitations. The magnetrons and klystrons necessary for frequency-tunable high-power radar transmitters required precision manufacturing capabilities and materials that Japanese factories, battered by American bombing and starved of resources, could not provide. Prototypes built in small numbers showed promise, but never reached operational deployment in meaningful quantities. An alternative approach involved increasing radar power output, attempting to overcome jamming through brute force signal strength. The theory was sound if Japanese radar transmitted pulses powerful enough. The reflected returns might be detectable even through American jamming noise. However, this solution required electrical generating capacity that Japanese warships, designed before electronic warfare became critical, simply did not possess. Retrofitting ships with more powerful generators and radar transmitters would have required dry dock time measured in months, time the Imperial Japanese Navy did not have as American forces advanced relentlessly across the Pacific. The most desperate countermeasure was also the most primitive, abandoning radar entirely and reverting to optical targeting methods perfected before the war. This represented an admission that Japan's technological development had failed, that the nation which had pioneered so many innovations was now retreating to pre-radar tactics, while its enemy operated with electronic systems of incomprehensible sophistication. Captain Tameichi Hara, commanding the destroyer Yahagi during the final months of the war, described the psychological impact in his memoir. "We were ordered to rely primarily on visual observation and optical rangefinders rather than radar. Our training had emphasized radar as the future of naval warfare, Now we were being told to ignore it because American countermeasures had made it worse than useless. It actively misled us. The admission implicit in those orders was devastating. We had lost the technological war. The broader pattern of American electronic warfare superiority extended far beyond simple radar jamming. Throughout 1944 and into 1945, Japanese forces encountered American technological capabilities that seemed to multiply faster than intelligence could track them. American submarines carried radar that could detect ships and aircraft from ranges Japanese submarines could not approach. American aircraft carried airborne radar that allowed night interception of Japanese bombers attempting to strike under cover of darkness. American ships coordinated through radio systems, using frequency hopping techniques that made Japanese radio interception nearly impossible. Each technological revelation reinforced the same psychological pattern: initial confidence in Japanese systems, confusion when American countermeasures proved effective, and eventual resignation that the technological gap could not be closed with available resources and time. Japanese naval officers, trained to believe in their forces' qualitative superiority over numerically stronger opponents, found themselves confronting an enemy that possessed both quantitative and qualitative advantages across virtually every dimension of naval technology. The human cost manifested not in single catastrophic battles, but through cumulative attrition, as Japanese ships operating without effective radar fell victim to American forces whose electronic eyes saw clearly. At the Battle of Surigao Strait on October 25, 1944, the same day as the Battle off Samar, Japanese Admiral Shoji Nishimura led his force into a perfectly executed ambush because his radar systems, jammed by American equipment aboard PT boats and destroyers, failed to detect the American battleships waiting in the darkness. Nishimura's flagship Yamashiro and battleship Fuso were destroyed by radar-directed gunfire from American battleships, whose crews could see the Japanese formation clearly on their screens, while Japanese radar operators stared at displays showing nothing but interference. The one-sided slaughter demonstrated conclusively that radar superiority, specifically immunity from enemy jamming, had become as important as firepower or armor in determining naval combat outcomes. Japanese destroyer and cruiser losses throughout the Philippines campaign followed similar patterns. Ships maneuvering without reliable radar information blundered into American ambushes, failed to detect incoming aircraft until too late, and could not coordinate fleet actions effectively. The Imperial Japanese Navy had been reduced to fighting visually in an era when warfare was increasingly electronic, like attempting to fight a modern battle with weapons from the previous century. Statistical analysis conducted by the United States Strategic Bombing Survey after the war documented the catastrophic effectiveness of American electronic warfare against Japanese naval forces. Of 21 Japanese capital ships present at the beginning of the Philippines campaign in October 1944, only 7 survived to January 1945. While multiple factors contributed to these losses, American air superiority, submarine attacks, and surface combat post-battle analysis consistently showed radar jamming had degraded Japanese tactical effectiveness by estimated 70 to 80% in surface engagements. The survey's interrogation of surviving Japanese naval officers revealed the psychological dimension underlying these statistics. Captain Omi, the radar research director, provided perhaps the most comprehensive assessment. By early 1945, Japanese naval officers no longer trusted radar information during combat operations. If the screen showed clear returns, we assumed American jamming was temporarily inactive. If the screen showed interference, we knew we were facing forces equipped with electronic warfare capability. Either way, we reverted to visual observation and optical rangefinders. The expensive, sophisticated radar systems we had worked so hard to develop and deploy had become ornamental. American electronic warfare had achieved something more devastating than destroying our radar. It had made us afraid to trust it. This psychological effect, technological intimidation, leading to self-imposed abandonment of available systems, represented perhaps the ultimate success of electronic warfare. American jamming did not need to be 100% effective. if it created sufficient doubt that Japanese commanders chose not to rely on radar even when it might have been functional. The mere possibility of jamming was enough to neutralize Japanese radar advantages. The industrial disparity underlying this electronic warfare superiority was staggering in scope and consequence. While Japan struggled to manufacture hundreds of radar sets throughout the entire war, American factories produced radar equipment in quantities that Japanese intelligence analysts initially refused to believe. The radiation laboratory at MIT alone coordinated development and production contracts for over 150 different radar systems during the war. American companies, including General Electric, Westinghouse, RCA, Raytheon, and dozens of smaller contractors manufactured radar components using standardized designs that allowed rapid scaling of production. By 1944, American shipyards were installing multiple radar sets on every vessel from destroyer escorts to battleships as standard equipment. The Essex-class aircraft carriers, which America produced at a rate of one every 6 weeks during peak production in 1944, each carried at least 7 different radar systems, covering air search, surface search, fighter direction, and fire control. This represented more radar equipment on a single American carrier than the entire Japanese combined fleet had possessed in December 1941. The electronic warfare equipment specifically designed to jam enemy radar followed similar production patterns. The TDY jammer that had blinded Admiral Kurita's fleet off Samar was just one model among dozens developed for different tactical situations. American factories produced spot jammers, designed to target specific Japanese radar frequencies, barrage jammers that blanketed entire frequency ranges with noise, and deception jammers that created false target returns to mislead Japanese operators. By late 1944, American naval vessels routinely carried 3 or 4 different jamming systems, allowing electronics officers to select optimal countermeasures based on which Japanese radar types they detected. Production numbers told the story of industrial capacity beyond Japanese comprehension. Hallicrafters alone manufactured over 40,000 radar jamming transmitters during the war. Bell Telephone Laboratories developed and helped produce over 20 different electronic warfare systems. The combined American production of radar and electronic warfare equipment between 1942 and 1945 exceeded 250,000 individual units, representing an investment of approximately $3 billion more than Japan spent on its entire naval construction program during the same period. Japanese industry could not approach these numbers. Total Japanese production of naval radar systems throughout the entire war numbered approximately 5,000 units. Electronic warfare equipment, jamming devices, radar warning receivers, countermeasure systems was produced in quantities measured in dozens rather than thousands. The Naval Technical Research Institute developed several promising jamming systems, but production facilities could not manufacture them in operationally significant quantities, while simultaneously maintaining production of basic radar sets, radio equipment, and other electronic systems the Navy required. Lieutenant Commander Nakamura, the radar officer aboard Yamato who had experienced the jamming at Samar, was assigned after that battle to the Naval Technical Research Institute to help develop countermeasures. His diary entries from this period, discovered in family archives in 1998, provide insight into Japanese awareness of the industrial disparity. January 15th, 1945. Today, I toured the prototype facility where we are developing our frequency-agile radar. The engineers are brilliant. The design is sound. We have built 3 working prototypes, but when I ask about production schedules, I am told we might manufacture 50 units by July if materials are available and if the factories are not bombed. 50 units. The Americans probably produce 50 radar sets every day. We are not losing the technological war because Japanese engineers are inferior. We are losing because American industry can turn good ideas into thousands of finished products while we struggle to build dozens. No amount of engineering brilliance can overcome this disparity in industrial capacity. The material shortages that plagued all Japanese war production by 1945 devastated electronics manufacturing, particularly severely. Radar systems required copper for waveguides, high-quality steel for antenna structures, specialized glass for cathode ray tubes, rubber for cable insulation, and numerous other materials that were increasingly unavailable. American submarines had severed the shipping routes that once brought tin from Malaya, rubber from Indonesia, and copper from occupied China. Domestic Japanese production could not compensate for these losses. Even more critically, radar and electronic warfare equipment required skilled technicians for assembly, calibration, and maintenance. Each radar set needed approximately 100 hours of precision work by trained electronics specialists. Japan possessed perhaps 20,000 such specialists across its military and civilian electronics industry by 1944. America had mobilized over 200,000 trained electronics technicians, radio operators, and radar specialists, with training programs graduating thousands more monthly. The human capital required for electronic warfare existed in vastly different proportions between the two nations. The cumulative effect manifested at Okinawa in April 1945 during Operation Tengo, the final sortie of the super battleship Yamato. Admiral Seiichi Ito commanded a surface force centered on Yamato, ordered to steam toward Okinawa and beach the massive battleship as an unsinkable gun platform supporting the garrison. Intelligence predicted heavy American air attack, making radar crucial for coordinating the fleet's anti-aircraft defenses. The reality was worse than anyone anticipated. American carrier aircraft detected Yamato's force shortly after it cleared the Bungo Strait between Kyushu and Shikoku. The fleet's radar systems, including Yamato's sophisticated Type 21 and Type 22 sets, were immediately jammed by American electronic warfare aircraft orbiting beyond visual range. Lieutenant Commander Nakamura, still serving aboard Yamato as Chief Electronics Officer, watched his displays fill with interference as American jammers activated. "We knew what was happening immediately," Nakamura recalled in his 1953 interview. "The Americans had detected us with their radar, which worked perfectly. They jammed our radar, which became useless. Then they attacked with hundreds of aircraft while we fought blindly. We shot down perhaps 10 aircraft from the 386 that attacked us. If our radar had functioned, we might have shot down 50 or more. But we were blind. The Americans saw everything. We saw nothing until bombs and torpedoes were already striking." Yamato absorbed multiple bomb hits and at least 10 torpedoes before capsizing at 14:23 hours on April 7, 1945. Admiral Ito and 2,748 crewmen died with her. The survivors, including Nakamura, were rescued by Japanese destroyers and returned to Kure. The official report attributed the catastrophic losses to overwhelming American numerical superiority. Unofficially, surviving officers understood that electronic warfare had played a decisive role. Yamato's formidable anti-aircraft battery had been rendered far less effective because American jamming denied her radar the early warning and tracking data necessary to coordinate fire against massed air attacks. The final months of the war saw Japanese naval forces increasingly conceding electronic superiority to American forces. Orders issued in June 1945 instructed remaining Japanese warships to minimize radar transmission, as American forces had demonstrated capability to track radar emissions and target them with radar-homing missiles and aircraft. The irony was profound. Radar systems developed to provide Japanese forces with enhanced detection capability had become liabilities that betrayed ship positions to technologically superior enemies. Captain Hara, commanding destroyer Yahagi during the Tengo operation until her destruction by American air attack, had watched Yamato die while his own ship fought with similar technological handicaps. His memoir reflected the despair that technological inferiority created. "We had been ordered to die gloriously in a final battle. Instead, we died uselessly, shot to pieces by an enemy we could barely see because they had blinded our electronics. There was nothing glorious about being destroyed by forces possessing technological advantages we could not overcome. The young men who died aboard Yamato and Yahagi deserved better than to be sacrificed in battles where they never had a chance. American electronic warfare ensured they never had a chance." Post-war interrogations of Japanese naval personnel, conducted by United States Strategic Bombing Survey teams, revealed the comprehensive scope of Japanese technological awareness by war's end. Officers and technicians understood not just that they had been defeated, but specifically how American electronic warfare superiority had contributed to that defeat. The interrogation of Vice Admiral Takeo Kurita, conducted in October 1945, included extensive discussion of the Samar engagement. The radar jamming completely disrupted our tactical coordination, Kurita testified, according to transcripts preserved in the National Archives. Without accurate radar intelligence, I could not determine enemy composition, strength, or exact positions. Visual observation was inadequate at combat ranges and through smoke screens. This technological blindness forced me to make decisions based on incomplete information. In retrospect, I understand that the American force was much smaller and more vulnerable than I assessed at the time. But without functioning radar, I had no way to know this. American electronic warfare achieved strategic victory without firing a shot. They made me believe I faced forces strong enough to destroy my fleet, when reality was quite different. This admission that electronic warfare had achieved strategic effects through psychological rather than physical destruction highlighted the sophisticated nature of American electronic combat capabilities. Japanese forces had not been destroyed by jamming, they had been deceived and intimidated into making decisions that led to their defeat. The technology had operated on human psychology as much as on electronic systems. The broader lessons learned by Japanese naval personnel spread through post-war Japan as survivors returned home and began reconstruction. Many former naval officers took positions in Japan's emerging electronics industry, bringing with them hard-earned understanding of how technological competition determined outcomes in modern warfare. Companies like Sony, Toshiba, and Mitsubishi Electric hired former radar officers and technicians who carried institutional knowledge of Japan's wartime technological failures. The influence was subtle but pervasive. Japanese electronics firms in the 1950s and 60s emphasized quality, reliability, and technological innovation over pure size or impressive specifications. The memory of building magnificent battleships like Yamato that lacked the electronic warfare capabilities to survive in combat informed a generation of engineers who understood that integrated technological systems mattered more than individual impressive achievements. Japan's post-war economic miracle in electronics manufacturing was partly built on lessons learned from wartime electronic warfare defeat. Former Lieutenant Commander Nakamura, who survived the sinking of Yamato and emigrated to the United States in 1952, eventually earned a doctorate in electrical engineering from Stanford University and worked for IBM developing computer systems. In a 1987 interview for the Naval Institute's Oral History Project, he reflected on how his wartime experiences influenced his post-war career. When I watched my radar screens fill with American jamming at Samar and again at Okinawa, I understood that technological competition would define the future. Nations that could innovate faster, produce better equipment in larger quantities, and integrate systems more effectively would prosper. Nations that fell behind technologically would fail regardless of their people's courage or determination. This lesson drove me to pursue advanced education in electronics and to contribute to technological development. Japan had lost the war partly because we lost the technological competition. I was determined to help ensure Japan would not lose future technological competitions. This perspective was shared by thousands of Japanese veterans who carried similar lessons into post-war reconstruction. The psychological impact of technological defeat, the experience of fighting with inadequate equipment against enemies possessing superior systems, created a generation acutely aware of the importance of technological competitiveness in determining national success. The economic policies that drove Japan's recovery emphasized education, research, industrial innovation, and quality control, all informed by wartime lessons about the costs of technological inferiority. Up next, you've got two more standout stories right on your screen. If this one hit the pat tip mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.